I've received some feedback after my first movie that predominantly had to do with fuels that I might be able to burn in this Coleman stove. We know that it is possible to use gasoline as well as other fuels and possibly alcohol, albeit not too well, in an unmodified stove. However, it was asked what the performance would be with regard to the test that I had already conducted with the boiling of water, the measurements that I had used previously. And I think that I am able to do that with what I have here. I do have, and my bottle broke when I opened it, I do have alcohol. This is denatured alcohol. I also have alcohol that I use for electronics. This is 99.9% pure alcohol, but this generally is not the type of alcohol that people would have laying around for electronics cleaning. Also, I was asked about gasoline, and generally when people talk about using gasoline in a stove, they're talking about ethanol free. But what I wanted to do here, if you were in a situation where you needed gasoline in a Coleman stove for whatever reason, you probably wouldn't be driving around looking for a gas station that had ethanol-free gasoline. So what I wanted to see, since I have no problem going and opening this up and cleaning it up afterwards, what would be the performance to run E10 or maximum of E10 gasoline in the stove and repeating those tests again. The alcohol in a canister that broke is in my Planters Peanuts can here. For good measure though, I'll let you know that this is the alcohol that was in that can, and it listed as a clean burning fuel for marine stoves. Make sure everything's purged. Okay, now I'm going to connect it. There's definitely a different color. Probably some impurities in that alcohol. I'll tell you that after a lot of work and testing and cleaning and rebuilding of this device, conclusively, alcohol does not function stably on this stove. I had just shown before, which was something that actually happened several days ago in my initial testing, when you have it in this position on vapor mode, when it's running off the vapors in this tank from the top, you can see that alcohol lights up and it appears to run okay. However, when you eventually switch down to actually using alcohol as a fuel source, things quickly start to fall apart. It doesn't work right. It collects in here. It pools up. It doesn't mix well. Eventually, it floods. The minor amount of adjusting that you do and tweaks causes it to spray in there and flame up or burn out. Just nonstop problems trying to get alcohol to run on this stove in any type of stable manner. So there's no way to run alcohol and measure the performance to boil water. You just can't keep it running with a flame that's consistent long enough to do so. Therefore, I'm not going to be using alcohol in this test. I'm going to move on to the next fuel source. If anybody's interested, I could take all of the information that I captured with the rebuilding and the cleaning and the attempting to run alcohol and put that in a separate video. But this is all I'm going to say about alcohol. I'm not going to do it anymore. And I'm going to recommend to people not to run alcohol in these stoves because it's not safe, it's not stable as a fuel for this stove. The next fuel source we're going to try in this stove is going to be 1K kerosene. This is the cleanest kerosene that I could get a hold of for this stove. And I'm not going to lie, number one, kerosene is not cheap, especially in a quart size container. And this stuff smells god awful. So you would have to be in a pretty desperate situation to be running kerosene in the Coleman stove, but in the spirit of science, I'm going to run it. Just like with the alcohol, we're going to start with a functional test, and I'm going to turn this up, and we're just going to see how easily the vapors ignite. I know that kerosene is probably not going to work well when it's cold, and it's probably going to require us to heat up the generator first, but we're just going to give it a go. This is room temperature, you know, just touching it like that. Stuff stinks. So the vapor does not ignite with kerosene as I expected. You could just see clouds of it coming up. This is going to be preheated before this will work. There's just a little fire going in some tin foil with a little paper towel. This is just to heat up the bar. Let this run for a minute or so till the generator heats up. Yeah, see, it's hot enough now. Kerosene is hot enough to be self-sustaining. I'm just giving it a little bit and let it heat up further now. I'm letting those little pieces of paper towel burn out. And kerosene is starting to turn blue. Very nice. I'll bring it up closer. Oh, look at that. It's a nice flame. So I'm gonna light up the second burner to measure performance. There we go. We got nice blue flame now on both of them. You really got to see this. Let me check the air. Pressure's good. Pressure's holding on the tank very nicely. There's a lot of back pressure here. So let me turn these up a bit. You can see what we're looking at. I know I got some black soot formed on this one from the initial turn up, right? The initial turn up, as we've seen, is not terribly pretty with kerosene. It's going to require cleaning. We knew that going into it, but it definitely looks nice. Let's crank this one up. Right? And then we have double burners running. Blue flame looks right now just as good as Whitegas. Once you get it really hot, once this thing really is churning, kerosene looks to be running just as good as Whitegas, in my opinion, and that's what this is showing right now. I think we've reached a point now where we could start the water test. So I'm going to shut off this burner. I'm going to bring this one down to standby. I don't want to bring this one too low because I want that generator to stay hot enough to maintain this performance in the kerosene. Again, we have to remember it's not Whitegas. So I'm leaving it right there. I'm going to get a liter of water ready and we're going to begin. 1 liter of water. I'm going to crank it up and we're going to begin. Looks like 6:16. The water's coming to a boil now. So we can see it's at a full boil here by 6:20. So we're going to say 6 minutes and 20 seconds is a full boil. This is what I'm going to do. I'm going to turn this down. I'm going to bring the pot down to temperature. I'm going to get rid of this water. And then we're going to do the 1 cup test. I have the pot now cooled down, room temperature. You see me holding it. I'm going to pour exactly 1 cup water into the pot. Going to repeat that test now. We can see the water is starting to come to a boil now at 1 minute and 40. And we'll see what a full churning boil is. Yeah, by 1 minute and 40, that was as big as the boil got. So yeah, as it turned out, the kerosene performed really nicely. It didn't stink that bad once it got started. It was more difficult to light, but all I did, like I showed before, is I wrapped some paper towel in some tin foil balls, put it on the front and back of the generator. I had added some kerosene into those paper towels, which is what really stunk, actually, and lit it for a couple of minutes till it heated that pipe, and then off it was. And then it took another couple of minutes for this to come into its own and really get hot enough to run like this, nice and blue, without any other flames coming out. But really, it runs just like Whitegas. It doesn't smell like I'm here, and it's not offensive. Some of the carbon that's on here is actually burned off at this point, so it's actually gotten a bit cleaner. And we'll open this up later and do an inspection and see what everything looks like inside, having run kerosene through this and doing this torture test. So I think this concludes the work with the kerosene. 2 thumbs up. Last of the vapors burned out. There was no black smoke or anything. It burned out clean. It's now off. I do smell a strong kerosene odor now. This having been already shut off. This is like kerosene lamps or whatnot. You always get this at the end. Again, I wouldn't run this inside, right? There's just Whew. It's just my observation, is what it is. You're definitely reminded it's kerosene once it shuts off. Aside from the soot that we already saw formed on the burner and the outside of the generator here on the assembly, I'm just going to open it up and take a look at the inside and see what we have on the spring and needle assembly. It's not terrible, but I could see, based on what I see here, a silhouette from the spring. I really want to take the spring out and have a look, because we could see this is where it was on the generator. This is where it heated up, and I imagine there's probably some deposits on the spring itself. The spring is nice and clean. I mean, there's really no deposits on the spring. This is not a horror show at all. I will point out that before I change fuels, I always clean this up, as I will clean it again and get this back to new. There's no crust on here. We're just seeing kerosene. That's it. This is nice and clean. No worries at all. Take a little diamond paste right here and pull off this carbon for our next test and make sure everything is clean so I can see what changed. Do this piece first. I'll do the needle. That way all the tests are consistent. It always starts off brand new and clean. This is what I've been doing. Like brand new. All ready for the next one. As we move over to gasoline, I'm telling you, we're up in the ante. I was heading over to the gas station and I saw this jug. I pulled this out of my shovel head right before I was doing my engine rebuild, emptying the tanks. This was in there for, I don't know, maybe 2.5, 3 months before I drained the tanks. It's not, nasty or putrid or anything of that matter, but it's not fresh gasoline straight from the pump. So here's a situation where you have gas stored for a while. It's a little bit dingy, got a slight yellow tinge to it, but I said this is what we're gonna go with, right? So I took it, I loaded up in the can, and then what I did was I purged it. I ran it full open into another container to purge out any of the residual kerosene that may have been coated on the spring or in that pipe from the previous cleaning. So now what we have is gasoline only, 87 octane E10, probably 2.5 months old, maybe 3 months old, leaning more towards 2.5 months old. Okay, so we'll begin our regular performance test. We're going to do it in the up position, burning vapors only. I'll get the lighter going right here. Turn the knob up. Ooh, that kicks right off, doesn't it? That's vapors only. And gasoline burns nice. I'll give it a sec to heat up. Probably shouldn't take too long with gasoline. Yeah, that is something. A lot easier than kerosene. Now I'm going to put it in the down position. Yeah, how about that? And that is E10. That is old gas. Yeah, absolutely perfect. Let's let that warm up a bit. We'll get the second burner going. And get some more kerosene fumes. And gasoline's behind those kerosene fumes. That looks like the gasoline right there. Now the gasoline is lit. Bring it up a bit more now to support both of them. Still has to purge out what's in that pipe right there. Speed things up a bit. Well, that's a real nice flame. That gasoline burns really strong. Really strong. Even with both burners going. We'll just get underway with 1 liter of water again. Five minutes and 25 seconds we're looking at for boiling water. Pot cooled down again. Holding it in my hand. Going to add Exactly 1 cup of water to the pot and repeat the test. Minute and 45 seconds it is boiling. So gasoline ran awesome on this thing. What we're going to do is we're going to shut this down now, and I'm going to take this apart again. We're going to just look at the generator. We're going to see the condition of it, and then I'm going to do a double control. I'm going to go back to Whitegas, and then we're going to record these values one time. Not going to do all the fanfare. I'm going to throw the pot right on, 1 liter, 1 cup, measure them both again, and see what those values are, just because I want them to be aligned with the temperature outside, what we're doing today and everything. See what the final values are for the results of this test. I've done the breakdown from the gasoline, and we can see the buildup right here in the same location we saw from the kerosene, right? It fared no better or worse in that regard. So I'm going to clean this up right here. From the needle, everything looks fine. It's always that one location though, it would appear, right? So we'll see what happens when I break it down after I do the final control with the Whitegas. As for the spring, everything looks fine. I don't see any buildup accumulating on the spring itself. That's clean as well. So I'm going to clean all this stuff up. I'm going to reset for the final test. I got everything back together. There's not going to be any performance testing. I'm just filling it with Whitegas as a final control, and we're going to just jump right into the boiling times. Probably some residual gasoline in there too. And push its way out now. Looks like it's 7 minutes. We have a boil. And now, just 5 seconds after, we're now at a full boil. But I'm going to say at 7 minutes it started to come to a boil. Now do 1 cup of water. And it looks like we're seeing boiling at 235, and that is the extent of the boiling. I wanted to be sure. Yeah, so the boiling capped off at 235. I'm shutting down the control. Let this cool down. I thought the video was going to come to an end here, and I was just going to clean this out and inspect it, and that was going to be it. But looking at the results here, gasoline burned the fastest. This is with the 1 liter, the most accurate. 525, followed by kerosene, which I would expect to take longer to boil water than gasoline. But the naphtha took 7 minutes, and I'm like, wow, how could that take longer than gasoline and kerosene? There's got to be something wrong here. Could it in fact be the fuel? Is it too old? And yeah, this is an old can, and I've had it around for like 10 years, and it's rusted. Maybe the stuff is rank or whatnot. I mean, it works good, but if you needed fuel that was high performance so you could carry more energy in a smaller volume, wouldn't you want to know if newer fuel performed better than old 10-year-old fuel on the shelf? So this is what I went and did. I went out and bought a brand new can of fuel yesterday. This is a Crown Whitegas. I have not even opened this can yet. This is brand new. I'm going to empty out this tank. I'm going to refill it with the fresh Whitegas from the Crown. I'm going to let it run a little bit to purge whatever's left in the line and what have you. Then I'm going to redo the test, and we're going to measure as a second Whitegas. This is going to be the new Crown Whitegas, to see if the times are the same or if they're dramatically different. Let's find out. And it's just been completely drained. While I'm purging the lines, we'll just put this through its paces. We'll fire it up. All the old gas should be gone. We're going to begin with the 1 liter test now. .445, we're seeing the boil. Now we're going to do the 1 cup test. Minute and 30. It should come as no surprise that the Whitegas left basically no residue whatsoever on any of the equipment. This is perfectly clean as from the last time I had cleaned it. It is just a clean burning fuel, as one would expect. So it would seem to me that even if my numbers were off slightly, there's definitely a degradation in performance given a same volume for white gas that sits over a long period of time like this can, as we have seen. It doesn't mean it's no good. If it were stationary, I mean, we've watched me use this fuel with absolutely no problem in the stove, and it worked great. But if you are on the move and camping and you want more energy in a smaller, lighter form, you would definitely want to go with something newer that's fresher and didn't probably absorb a lot of moisture. I imagine this probably absorbed a lot of moisture, and that's why it has less energy per pound or per liter or what have you, right? So that's very interesting what those numbers have provided. So I think this concludes my video on running Coleman stoves on alternative fuels. I hope you found this video enjoyable and informative. Thanks for watching.